Hi there, algebra students. Please pull out your Dilations Notes packet. Starting at the top, we are going to fill in some blanks here. What a dilation means in terms of math is it's a transformation that produces an image that is and you're going to fill in same shape as the original, but not the same size. A dilation is similar to the original figure, and dilations are always centered around the origin, which is the point 0, 0, unless they tell you otherwise. We talk about the degree that we're dilating something by as the scale factor. It is equal to the fraction of the image length over the pre-image length. And just a reminder on the vocab there, the image is the new figure after you've done the transformation. The pre-image is your original figure. This is a ratio, which you learned about in 7th grade. If the scale factor is greater than 1, the figure becomes larger. But conversely, if the scale factor is between 0 and 1, the figure becomes smaller. So we're not talking about negative values here. We're talking about things like 1/2 or 1/4. That would produce an image that is 1/2 the original size. Now, the notation here is really important because you'll see this on the PSSA and the Keystone as well this year. You're taking an original point, which we list as x comma y, and we're multiplying it by whatever the scale factor is. We're using the letter F to represent the scale factor, so it goes to the x and it goes to the y. So if you take a look at example 1, if the scale factor is 3, how would you write the rule? Well, we're taking the original point, which is an x and a y, and we're multiplying them each by 3. So that will look like 3x and 3y. For example 2, we've got a triangle with vertices of 0, 2 for our point A, point B is at 4, 4, and C is at -1, 4. And you don't even need the graph to figure this out because we're using a scale factor of 4, which just means each of those x's and y's gets multiplied by 4. So go ahead and fill those in for me. The way I'm going to set up this problem is I'm going to write the original ordered pairs underneath example 2 like I did there with the label of their letter. And then I'm going to draw an arrow representing the transformation. And then just a reminder on the notation here, this is a transformation, so after we're done, we're going to use that little apostrophe. And we're going to write the new ordered pairs. If I take 4 times the original ordered pair for A, I get 0 and 8, because 2 times 4 gives me 8. For B, I'm going to get 16 and 16. And for the image of C, we're going to get -4, 16. Here we're looking at, for example 3, a quadrilateral. It has the vertices P, Q, R, and S, and it's dilated by a scale factor of 1/2. So we are going to go ahead and plot the coordinates of the image, but before we do that, let's go ahead and plot the original quadrilateral PQRS. So there's my original quadrilateral, and now what I'm going to do is I'm going to switch colors and I'm going to go ahead and plot the dilated PQRS. Before I do that, what I want you to do to the side is I want you to write the new ordered pairs for PQR and S. So the new ordered pairs are what I would get after I multiply these by 1/2, the scale factor. And so my new coordinate for P, the image of P would be at -1, 2, Q would be at 2, 2, and R would be at 2, -1, and S would be at -2, -2. So go ahead and plot those points on your coordinate plane. So there's my image of the quadrilateral PQRS. And now for part B, what we want to do is we want to demonstrate that they're similar. So you want to look at the ratios of the length. So if we go back to the original quadrilateral, that had lengths of, for instance, side PQ was 6 blocks long, and side QR was also 6 blocks long. We can't find SR or SP because they are diagonal and we'd have to use the Pythagorean theorem. So let's just stick with side PQ for right now. Oops. So side PQ, and we also talk about QR, and each of those were 6 blocks long. But if we look at the image on the new figure, and we count those out, that PQ, on the new rectangle, is 3 blocks long, and this is QR is also 3 blocks long. So if we look at the image, it is 3 blocks long on both of these. QR is also 3. So both of those are going to reduce to be equal to 2. And what that tells me is when we get the same ratio answer, when it's simplified, that demonstrates that it is a similar figure. The last question for question C says, what do you notice about the angle measurements of the two figures? So I want you to pretend, and you don't have to draw this on your figure, but I want you to pretend that you cut out the image PQS, that angle right there, and we laid that on top of the original image. If you look at those two angles, they are the same angle. And if you look at another angle, let's look at angle R on the image and angle R on the original image, those two also look to be the same. And that is because they are. Despite the fact that the side measurements changed, the angles maintain their degree. So what do we know about the angle measurements of the two figures? They are the same. And just a reminder back to 7th grade, similar figures have different side lengths, but they have equal angles or equal angle measure. Looking at example 4, if the scale factor was 5 halves, and you can think of that like 2.5, how would you rate the general rule? Well, is it an enlargement or a reduction? Because this number is greater than 1, it is an enlargement. And how would we write the rule? With that same rule notation, 5 halves x, comma, 5 halves y. In example 5, you're looking at the quadrilateral, which is an image. It's a dilation of the original quadrilateral ABCD. So the first thing I would do is I would circle the original image, or maybe highlight those original ordered pairs so you can see the big one around is the original. We want to find the scale factor and we want to classify it as an enlargement or a reduction. Well, clearly when we look at the original quadrilateral, and I'm going to trace it quickly here, to the new inside of it, that's a reduction, which means it got smaller. And if you look at the original ordered pairs, like for instance, if I pull out point B and I look at it in the original figure, that was at the point 0, 6. In the new image, it went to the ordered pair 0, 2. So I have to think about what would make it go from 6 to 2, what would my scale factor be? And so I'm thinking about 6 to 2, or 6 over 2 would be 3. So that means that the big figure is 3 times bigger, but we want to multiply to get it smaller. So what times 6 gives me 2? Well, x would be 1/3. So my scale factor is 1/3. So for the last example, we want to look at the triangle that's given, and we want to use a scale factor of 2 to find the new image, the new triangle x, y, z after a dilation. So I've already written the original ordered pairs for x, y, and z to the side, and then I'm going to multiply each of those by 2 to get my new ordered pairs for the image. So the image of x is going to give me -2, -2. The image of y will be at -2, 4, and the image of z will be at 2, 2. And then I want to plot those on the graph. So there I've plotted my image, and the thing I want you to see is not only did it get bigger, twice as bigger, but you'll take a look at this the original figures right here inside, but it's not completely centered like you would think. Some of the other examples we've looked at, the image is perfectly centered in the middle, or the original's perfectly centered in the middle. So you just want to be cautious that you don't think that always has to happen. And then it says, what will the coordinates of point y be if after a reflection of the polygon, the image of x, the image of y, the image of z over the x-axis? Well, that is talking about one of the past packets with the reflection, and the correct answer should be that y, the image, that double marking, would be at -2, -4, because if you look at the image of y right here, if I flip that over the y-axis, it would be, or the x-axis, pardon me, it would be all the way down here. So that would be my reflected point. Make sure that you bring any questions for your math teacher the next instructional day, and make sure also to watch the video on rotations as well.